right, we can't get to the 4-day weekend until we pass through today. You know what I mean?
Yeah.
IDT applied to time, exactly. So, here we go. Uh, we, or to weekends, if you like. So, do you recall, way back in pre-calculus, the double angle identity for cosine?
No.
Oh, that's a pity.
Two,
It is, one of them is cosine of 2a is
cosine squared of x minus
cosine squared minus sine squared. Super duper. Okay. There were equivalent forms that had cosines only. Do you remember how you get to cosine only, no sine?
cosine squared of a minus 1.
Okay, so yeah, if you replace the sine squared with 1 minus cosine squared, then eventually you get cosine of 2a equals 2 cosine squared minus 1. True. We'll need that in a minute. How could you get that first identity in terms of sine only on the right?
1 minus 2 sine.
Yeah, by virtue of the same kind of substitution idea, 1 minus 2 sine squared. All right. You with me so far?
Yes.
All right. Now, in pre-calc, you use these for finding cosine of 15 degrees or something. I don't really care. In calculus, you do them for totally different reasons. And the reason is for power reduction. I'm going to skip these. I don't like those. In calculus, we use these for a different purpose. Power reduction. From square down to first degree. Okay? Now, that said, sine squared and cosine squared are what you're going to want to replace. So, working this out, if you solve this for sine squared, I'm using u instead of a, but it doesn't matter. Solve that for sine squared, please. Okay, that silence was not what I was looking for, so try again. In solving for sine squared, what 3 things would you do? Actually, what 2 things would you do?
Subtract 1 and divide by 2.
See, that wasn't so hard. Now, that probably then would be switched. 1 minus, oops, darn it. Let's go with 1/2 minus 1/2 cosine of 2u. Yay? Okay. What about cosine squared? If you solve for cosine squared, what would you get? 1/2 plus 1/2 cosine of 2u. Woo. Okay, cool. Now, the idea of the day then is to integrate sine or cosine squared, you're going to use those identities. First, the temptation for students is to say sine squared, why not just 1/3 sine cubed? And I can assure you on the first test there will be a lot of people that give that a go. Why not that? Yeah, if you were to check that with chain rule, it's okay, the 3 goes away, sine squared, but then wouldn't you get a chain rule cosine that you don't have? And so that is 100% no, that thought. And so it's a little more complicated than that. That's why it requires power reduction. You down? Okay, so we're going to replace with an identity. Sine squared is 1/2 minus 1/2 cosine of 2x dx. In this case, the angle is x, yeah? Now, I'm not big on memorization, but there are sometimes you just need to have things memorized. This is one of them. You need to have that identity down in your brain. Now, how you go about integrating this is up to you. Most people, at least mentally, let's just, for note purposes, I'm going to go really slow by the book kind of stuff, yeah? You know that eventually we'll do a little more mental work, but for notes, we'll get it. Very thorough. All right, so what's the antiderivative? Do you agree I can split a difference into two intervals? Okay, so what is the antiderivative of 1/2? 1/2 x. That, I think, is good. Now, preferably this will be mental u sub, because I want to honor your time. Let's talk about, you're starting to get to the place where you can do a little mental u sub. Now, mental u sub, my thought process anyway, goes something like this. What's your u here? 2x. So what's your du here? 2dx. Now, wouldn't it be awesome if you had a 2 dx there, because then your du would be complete, yeah? Can I just say, hey, I feel like putting a 2 in? No, everything must be balanced, and so you would balance that 2 with a 1/2. Is this making any sense to you whatsoever, or should I actually use something? Okay, all right, so this then, if I use sub it, would be cosine u du. The antiderivative of which would be sine u, yeah? Actually, but it's not going to be u because I'm going to mentally sub back. So sine 2x, and so my antiderivative is 1/2 x minus 1/4 sine of 2x plus c. If that mental use sub just, you don't know what the heck I'm doing, use sub it. If you don't even need to put the 2 1/2 there, fine. I don't care as long as you do that well. You understand? Are you with me?
Yeah.
Okay. Try the other one on your own then, my young friends. ¿Listos? What's the first thing you did? Change cosine squared by power reduction identity. What is the reduction identity? Okay. All right, so the first you can integrate, and what about the antiderivative of 1/2 cosine of 2x? 1/4 sine of 2x. And that's it. If you want to guess and check it, cool. Mental u sub, cool. Real u sub, cool. Just get it right. You down? All right, now, let's talk little variations on the theme here. This guy has a bit of a different thing going on. It has that sine squared, but we have a different argument. So if I use an identity here, then what is the power reduction identity? 1/2 minus 1/2, sine is minus, cosine of 2 times 4x, so 8x. So think globally that this is, you always take double the given angle. So if it was u, then 2u. But if it was 4x, then 8x. Be cool? All right. Antiderivative of 1/2. And what about the antiderivative of 1/2 cosine of 8x? 1/16. How did you do that? Yeah, if u is 8x, then du is 8 dx, and so you're going to get 1/8 of a factor. Sine, yeah? All right. You follow? It is sine of 8x. You're right. Thank you. Okay, a little greater power. Cosine to the fourth. Now, if this is even, it's obviously very different than odd. When it's odd, you strip off the single like you have been doing, so don't lose that skill. But now, blend it with even. This is even, so it's not a split off a single one. Splitting off the single one would do me no good. I don't have an identity for a cube that would be left. It would go nowhere. So instead, what do you reckon we should do? Cosine squared is twice over, yeah. Cool. Then what? Identities? What's the identity for cosine squared? 1/2 plus or minus? Plus 1/2 cosine of 2x times 1/2 plus 1/2 cosine of 2x. You follow? All right. Let's do a little FOIL. When you FOIL this out, what's first? 1/4. What's the OI? Outer and inner. 1/4 plus 1/4, so I see 1/2 cosine of 2x, right? And what about O in FOIL? 1/4. Oh man. Now what? First one, fine. Second one, fine. Third one, not fine. What is to be done about cosine squared of 2x? Do it again. What is this power reduced? 1/2 plus 1/2 cosine of 4x. So 1/4 plus 1/2 cosine of 2x plus 1/8. I suppose I could combine those when I integrate. Plus 1/8 cosine of 4x. Dig? Alright, what's 1/4 plus 1/8 then integrate? 1/4 and 1/2 are both constants. 3/8 x. I agree. What is the antiderivative of 1/2 cosine of 2x? 1/4 sine of 2x. Lee? What is the antiderivative of 1/8 cosine of 4x? 1/32 sine of 4x. Plus C, senor. All right, and that's all she wrote. You follow? Okay, a lot of pre-calc work before the actual integrating. Last but not least, let's try an application. Try this on your own or with your math amigos.
I just did sine graph.
Eh? But you know the sine graph. Sine graph. You definitely better remember the sine graph, and I'm not just talking today or tomorrow. I'm when you're 85. I will come visit you in your nursing home, and I will say, show me the sine graph or else I'll beat you with your walker. Oh,
Sine graph
was
right there?
not.
Yeah, but here's a thought.
When I say the first quadrant region, I mean the first quadrant region. What is the period of sine of 2x? The period of sine of 2x is pi. So a half period is pi over 2. Washer or disc? Disc. the mental use of is then you don't have to change the limits if you can mentally use up the antiderivative. What identity did you replace with? 1/2 minus 1/2 cosine, double the previous angle, or what do you get? Oh, what's your total volume? Don't hear anything unexpected. I squared over 4. I squared over 4. Yep. All right, you with me? All right. Let's go to the first set of homework, which is 81B. And look at the replacements or the back or front, I guess it's front side. Front side answers, are you ready? Or give you a minute to get. That's cool. Is there anything special for a 30-week thing? Is that going to someplace work? Oh. Well, all right, number 34. What'd you get? 804.247. 1 for 1. 35. What'd you get? 15 pi over 2 or 23.5619. So 562 is cool. Sort of like 2 for 2, but not really. 36. 227.8701. Yay? This is 2477, so you could do 248 there, by the way, for 34. 37, what'd you say? 6.28318, which is probably 2 pi. 38. 686.9615. 39. 0.9424. You guys are good at these. 40. So 2 pi basically. 6.28. 41. 3017. Do I need to review place value? 3017.18. All I have is 3 decimals. I have 186. Is that what you have? All right. Questions on, this is 81B. Questions on 81B, front or back? Sorry, 3? 38? Okay, 38. 41. 35. 22.
And then 25 on the front.
45? Okay. 22, okay. Okay. Here we go. Let's do the replacements here first. Number 2038, rather. Okay. So the instructions said you should be graphing it and finding intersections on your own and using your calculator only to evaluate the integral, all right? So I should see work about finding intersection points. So for 38, when I say y equals 16 minus x, what kind of graph is that? What attributes? A line with a negative slope and a y-intercept of 16. So I would expect that. Y equals 3x plus 2 is also 3x plus 12, excuse me. 3x plus 12 is also a line with a y-intercept of 12 and a steeper slope. And what about x equal -1? That's a vertical line over here. So I've got that there region. Are we clear on the region? First of all, that's obviously very important that you identify the region correctly. Are we cool? Alrighty then. Let's go then around, where are we going around the x-axis? If I take any slice and revolve it around the x-axis, disc or washer? Washer, alright. So I start by saying, alright, here's my washer plan, and then I decide, alright, if it's around x, I use x, alright. Next thing, let's get the intersection points. I know the left edge of the region. Am I talking left to right or low to high? Left to right. The left is the vertical line -1, right? How do I find the right bound of the region? Intersection point 16 minus x equals 3x plus 12 means 4x equals 4. The right side intersection is 1, okay? Alright, last but not least, big R, little r. So when you look for big R, look at your picture and say, what's the far edge of the washer? Is the far edge of the washer the 16 minus x line or the 3x plus 12 line? 16 minus x is big R. What about the little r?
3x plus 12.
That's the 3x plus 12. And then you can use your calculator for that. That make sense? Any questions? So you figure out where you went wrong if you got that wrong? Why did you do that wrong? Okay, that's what you're here for, to figure out where was my mistake and learn from that mistake. 41. Is 41 still a question?
Yes.
Yeah, we don't have a lot of practice. We probably could do a better job of getting you sideways opening parabolas, not to mention the line is kind of wacky as well. So x equals 4 minus y. I had to slow myself down there a little. It's obvious that when y is 4, x is 0. And I also feel like when y is 0, x is 4, yeah? So I just use the intercepts to get the line. Cool? I try not to memorize rules about parabolas, especially sideways opening, because it's all different. Instead, I think, all right, when y is 0, x is 16. And when y is 4, -4, x is going to be 0. So with those 0 kind of ideas, I get a pretty good graph. You follow? All right, we're taking this around the y-axis. All right. All right. If it's around the y-axis, will I be using y or x for my variable? Y. If I use y for my variable, how do I draw a slice? Sideways, up, side to side, or up and down? Side to side. Y slices or rectangles have a dy height. And so if I reflect something like that, do I get a washer or a disc? A washer. Here we go then. Washer. Pi, big R squared. So R squared. We said we're using dy. Cool. All right. The bounds, are they going to be left to right or low to high? Low to high. That's y, low to high. 4 minus y equals 16 minus y squared. Get everything on one side. Y squared minus y minus 12 equals 0. It's factorable. You're welcome. Y minus 4, y plus 3. So y is -3 and 4, yay? Seems like it jives with my picture. Okay. So -3 to 4. big R, am I talking to the parabola or to the line? Parabola. And the line is here. That's the thought process. Any questions there? We clear? Bene, molto bene. 35. 35. These two ask questions, so I don't want it to be, oh, it seems so logical you do it, but when I do it, I don't really understand what I'm doing. X equals root y, x equals 0, and I changed this slightly in class. I said it didn't read very well, so change it to, instead of y is between 1 and 4, make it boundary lines are y equal 1 and y equal 4. That'll be a little more logical. X equals root y. What kind of graph is that? It's like y equals x squared, the parabola, but how is it different? Here, let's go y equals x squared. But that's x equals plus or minus y, yeah? But that's not the same, so how is it different than a full parabola? It's only half a parabola, the positive x side. So that's that curve there, yeah? All right, x equals 0 is this guy. And y of 1 and 4. So I'm thinking this region right aquí. You follow? Okay, and it's revolved around the y-axis. When I take a slice here and revolve it, do I get a solid disk or a washer? It is a disk. So, volume is pi r squared d, let's dy because it's around y. All right, cool. What is r? To the curve, to the curve, to the curve, to the curve. The curve is the parabola. So r is the parabola equation from 1 to 4, yay? And then it's always bewildering when somebody picks up their calculator from people like that. Are you kidding me? You can't integrate y. Y. You're integrating y. Come on, people. So, it's easier to do it without. All right. Are we good there?
Yes.
Been 22 is 22 from the book. The question
Indeed,
Yes.
yes.
Alrighty.
Yeah, I'm here.
Alrighty. For what values of k? K. So. Okay, cool. Do you agree cubes could look like this or like this? Positive cubes anyway. Which one of those would have two tangent lines parallel to the x-axis? This one. When should doesn't so let's translate that. If it's two tangent lines parallel to the axis, then it really means find k so that it has two horizontal tangents, yeah? And what does that mean? Horizontal tangents implies the derivative is 0 twice. Y prime equals 0 twice. Yay? Cool. All right. That's my thinking through my strategy. So now let's talk derivatives. Y prime equals 4x squared plus 4kx plus 5. This needs to equal 0 twice. Well, why wouldn't it equal 0 twice? parabola has two solutions, why wouldn't it always work? Talk to me, people. Parabolas sometimes have. No shift. It's only the top half. What kind of roots do you have from a parabola? Imaginary. So you need to make these real, right? Must have real zeros. All right, cool. Let's think in terms of, I don't want to get into trying to factor this or complete the square. Let's think quadratic formula. If I did the quadratic formula here, wouldn't I do something like negative 4k plus or minus b squared is 16k squared minus 4ac. We? All right. What does that, when would I have real zeros? Real zeros if, what makes one quadratic real versus another being imaginary? Square root has to be positive. 16k squared minus 80 must be positive. Let's just do a sign test kind of thing. If I solve this, k squared is 5, so k is plus or minus root 5. When k is less than negative root 5, do I get positive or negative? A big negative would be squared a big positive, so this would be positive or negative. Positive. 0 would be negative, and a huge positive, positive. So what kind of k values would give me 2 real zeros to the derivative and therefore 2 tangent lines horizontal to the axis? K must be greater than root 5 or stuff. All right. 25.
Yes.
25. Okay, so this is meant to prepare you for the mean value thing, which is in set 85. It's a huge idea of calculus. Most powerful theorems for proof of all. But you don't need to know that to do the problem. You just need to do what they tell you to do. Like a good little soldier. All right, so find the points on the curve where the tangent line is parallel to the segment. Cha-cha-cha-cha-cha. A visual is not necessary but helpful. Check this out, my friends. Okay, if you were to graph this, it has, it looks like this, yeah? You cool? Okay, they're saying if you take negative 3 and 1, there's a slope like that, yeah? All right. It says find the point on the curve where the tangent line is parallel to the line segment joining those points. In between these 2 points, there's got to be a point in here where the tangent line is like that one, yeah? Probably in there somewhere. The question is, where? Follow? All right, cool. Let's just start with putting it into calculus. I want a place where the secant slope equals the tangent slope. Talk to me about how you would find the secant slope of this line between 2 points. How do you find secant slopes? F of 1 minus f of negative 3 for the rise over 1 minus negative 3 for the run. That's the secant slope, and I'll get into that in a minute, but we'll calculate the secant slope. Are we cool? How do you find the tangents? The derivative, negative 2, I'll call this c, because it's some special number, yeah? Negative 2c minus 4, yeah? All right, cool. What's f at 1, please, just mentally? 7. What's f at negative 3?
15.
I agree with 15. Apparently this is sloping downward. My picture obviously stinks. Negative, did I do that right? Negative 9. Yeah, 15, yeah? Sorry, my picture is terrible, obviously. Negative 2 is the secant slope, yay? What happened to my graph? Symmetry, I didn't get the symmetry right. What a dummy, I'm sorry. Oh well. All right, so I need to find a place where the derivative equals negative 2. Well, that means it must be at negative 1. And you just did the mean value thing. Done. Okay, questions on 82. Yes. 37, uh-huh. What about it? Oh, do it? Oh, okay. Okay, 37 real quick. 37 is the sine curve and x equals pi over 2, which is a vertical line, and the x-axis. So you're talking this region around the y-axis, wait. So if it's around the y-axis, I use y. If I use y, slices like this, yes? This to washers. Washers. Okay, dy bounds 0 to pi over 2 or 0 to 1? 0 to 1. Big R, what is this distance? Pi over 2, what's pi over 2 every time? What's little r? Yeah, arc sine or inverse sine of y. And calculate. This is the sine curve, but it has to be in y terms. So you have to put it in y terms. And so inverse. Okay. Well, you gave enough questions that 82 is not going to be enough time, you little weasels. So great. Being able to grade this weekend over 4 days, I'll have to grade double on Tuesday. Ooh, 1 and 2? 82 on 1? 1 on 82? Right on. Let's try 1 on 82. All right. First. Probably only. Did you get your... Oh, okay, cool. Did you... Did you get your given? What does it say? What did you call? So did you define this as x? And you're given the x dt is x growing as it's pulled away from the wall?
Yeah.
So positive to some kind of units, yeah? B, dang it. Okay? What do they want? They want d theta dt, and when do they want it? Now. They want it when the top of the ladder is 5 feet above the ground. So when y equals 5, yeah? Okay. Bene, what equation did you use? Cosine, I guess you could do cosine, but don't you...
I like sine.
Sine is better?
Yes.
You could use tangent, but I don't think 3 variables. We'll finish it the next day. That's a good one.
Mr. Ribbon,
So we have to do a little substitution.
can I
Yes.
purpose set?
Oh, you told me that already. What do you want?
Can I reset, yes, 82?
Here